Okay, to wrap this unit up, we're talking about using formulas and the application of those formulas. So I think this is two birds with one stone type video for the next two exercises. And what we're just recapping, what we've been doing is looking at and mostly dealing with one letter, one pronumeral, and that's equal to something, and we're asked to solve for that. And it might look like that, and I'll get rid of that. It may even look like that, but the point is there's one pronumeral, one letter, whatever that letter is, we are solving for that. There's only one thing that could change, and there's only one possible answer here when we unwind all that stuff and get to the solution. Okay, it may even look like this, and there'll be only one solution there to make that true. And that's the type of work that we've been doing. So we just need to understand that they are equations. Look, they do have an equal sign in them. But now we've got we've actually got three pronumerals here. Each of the value of each of these things changes depending on the information we've got. So we're calling these formulas, okay, because we have two or more pronumerals and they're somehow related to each other, okay? And we understand this if we're driving or doing something, riding a bike. We can work out our speed is equal to the distance that we travelled and the time that it's taken. Now, if we fix the distance, if that's 2 kilometres, for example, that we need to ride our bike, and we push really hard and do that really quickly, well, we've covered that distance in a shorter amount of time. So our speed, the calculation of our speed, will end up with a higher number, and we'll end up at our destination and covered in sweat. So, or I could take it easy, and so the distance stays the same, but now I've taken double the amount of time, so I'd expect my speed to halve in that situation. All right, so that's the kind of thinking that we're often looking at now, and you know, there's a lot of smart people have worked out some very difficult relationships between different variables, and they've written out these formulas or equations to show how these things are related and allow you to come in there and do these calculations. There's 3 letters there, so to solve this we need to know 2 of those values. To calculate the speed, we need to know both the distance and the time. We could rearrange that formula, but you're not going to be asked to do that. And given 2 bits of information, we can work out the third. All right, so, and that's the game that you're in at the moment. So look at the questions very carefully and look at the letters and understand what those letters represent, and scan the questions, because there's often the bits of information you need is buried in the words or the explanation of the question. So drag all that stuff out and write it on your page. And I'll just take a couple of minutes now to show you a few more things on the whiteboard, and we'll wrap up this unit. Thank you. Now, we're talking about rearranging formula. So we had this equation, 3x plus 5, and we rearranged it to be x equals y minus 5 over 3, and I think I put brackets around that. So why I'm doing this and why I drew that graph, just remember, save you going backwards, that's 5, and that was minus 5 on 3, and it was a straight line graph. And what I was saying is there's one point, if you know an x value, you can work out the y value, and if you know the y value, you can work out the x value. So let's try this. Well, if x equals 4, so we put this in here, 3 times 4 plus another 5, we're at y equals 17. So x is the subject on this other equation, so why don't we put in y equals 17 and just convince ourselves that we get the same value back. So 17 take 5 divided by 3. So x is equal, 17 take 5 is 12 divided by 3, and that's equal to 4. So you can see how it works. So if this was our graph, this is 4, and we measured up here, this y value has to be 17 across here. So knowing how to rearrange equations or formulas or rules is a really important skill. And I've got a bit of room on the board here, and I know I've covered this before and we've done this before, but you always see questions like this where you have the formula for the change in degrees between the Fahrenheit and the Celsius scale. Okay, so that formula can be rearranged to make Celsius the subject, and in that formula you will have, if I just write it out, will be subtract the 32 over here. So we'll have F for degrees Fahrenheit, subtract 32, and we talked plenty about reciprocals, and the reciprocal of 9 over 5 will be 5 over 9, and that's the formula rearranged, and you can do it like that. Why don't I just, for the completeness of all this, I'll change the color again and we'll step it through. Okay, and we're always given one of the formulas and we're told to rearrange the other one. So how do we do it? We subtract 32 from both sides, and that was my first move there. Now there's a little bit of a trick here. I'm going to swap the left hand side and the right hand side over. So as long as I do that properly, we should be all good. And I'm putting brackets around that. I really like using brackets in the right kind of way to help keep things together in the right spot. So the key here is understanding multiplying by a reciprocal, because we can do 2 steps in one here, and those will cancel, and we'll be left with degrees Celsius as the subject, and buried in this formula there will be a spot when you're given the value of the degrees Fahrenheit, which is in here. You'll be able to substitute it in and you'll get your equivalent value in degrees Celsius. So I point that out because you can see how quickly I've rearranged the formula, and I've just got to say to you, this kind of thinking comes with, and the skill comes with practicing it and getting used to this way of working algebraically, rearranging formulas, making one thing the subject. So hopefully that's given you a bit of an insight into that, and I just know initially students aren't very confident with that, so you need to build that capacity. We're on to the application type questions that we get for the rules and the formula. So often some of the questions relate to we've got someone and we're working, I'm just going to draw my stick little figure here. We've got someone and they were playing a game of a certain age, and then if I sum the age of this year and next year, it's equal to something. So what is my age? So what that looks like algebraically, if I'm a certain number of years old now, and say next year I'll be the same age plus another year older, and for example that is equal to 19. And so the question is, what is my age? And it's a consecutive number game in disguise, and you can work this out without the algebra, because I think whoever this person is, if the sums of the two ages and the result is 19, well, I think currently he has to be 9 years old, and next year he'll be 10 years old, and they'll add together to be 19. But look, what does that look like algebraically? And this is the game that you're in. We can write this as 2n plus 1 because these brackets here don't actually mean much at the end of the day. And this would be a way of showing our working out here, and we're at 2n equals 18. So divide that by 2. So we're 9 years old, and next year we'll be 10, and they add together to give 19. So they're the kinds of games that you'll be put into. And so another question might be, you've got a brother and sister, and their ages are 2 years apart, and together they add to 30. So what does that look like? So if we use the same structure, n for the number, and the other person is 2 years older, so they are the same age as that person that we started with, plus another 2. And that was all equal to 30, I think I said. And so there's our algebra. And again, these brackets don't mean much. They just help me set up the question. And 2n plus 2 equals 30. Subtract 2, subtract 2. So what are we left with? 2n equals 28 and n equals 14. So this first person, who we called n, must be 14 years old, and their sister perhaps is 14 plus 2, so that has to be 16. And again, the numbers are small, and so you can get into a guessing game and you can work those things out. So another really good example of that style of thinking is, there's a question there that someone's watching the TV and they're watching it over 3 days. And I don't know, I'm going to say over 3 days from Monday, Tuesday to Wednesday, they've watched 14 hours of TV. Okay? And we've got the little game that we're playing here is for watching TV, let's use W. So we're watching TV, and then on Tuesday we watch twice as much TV. And so what does that look like algebraically? It looks like that. And then the question goes something like, well, on Wednesday I watched twice as much TV as I did on Tuesday. So that kind of looks like 2 times 2W. So let's write that as 4W in here. And we collect our like terms and we get something like, remembering that's 1W, we get 7W is equal to 14, and so W has to be equal to 2. So how much TV did I watch on Monday? On Monday I watched 2 hours, and then on Tuesday I watched double that amount, so that was 4 hours, and then on Wednesday I doubled that again, so that was 8 hours. And just double checking that I've got it right here, it adds up to 14. All right, so that's the kind of thing that you need to be aware of. it's so easy to come in here and say, oh, well, I'll create some different variables. Monday TV, Tuesday TV with a T and a W for Wednesday. And that's hard to solve because you got three things. And what they're trying to steer you towards is this thing where you just use the one variable and you collect the like terms and you see what you've got. So that played out here. We used N as the one letter, and it even played out here. And that's once you realize that game and you start playing that game well, then the algebra in these questions looks pretty straightforward. Now I've just got two questions to finish off here, and I really like these questions because they require you to tie a few different skills together here and combine a bit of understanding here. So we've got a measurement question here, we've got a rectangle, and the key here is to notice that the length of this line is the same as this line, and it allows us to construct one of our equations, and that equation to solve for x will be 2x plus 3 is equal to 10. So this is the same as this, so they must be equal to each other. And now that I've got this, it's quite an easy job to help me work this business out. So what have I got? Let's subtract 3 from both sides, and we've got 2x equals 7, and so the length of x, if we divide by 2, must be let's say 3.5 units in length. Okay, so does that make sense? 2 times 3.5 is 7, plus a 3 is equal to 10. And the other one here, the other equation that we can create here is 3y is equal to 6. These other two lengths here across here are equal. So y in this case will be equal to 2, and units, I'm not sure what the measurements were, so let's do that. And that is the unlocking there. The unlocking there was knowing that these lengths were equal, and once you see that, it becomes really easy. So I've got another question here which I think is one of the more advanced questions for you, and it's relating to a question on photocopiers, and they're saying something like this, that every copy you make is 35 cents, and we made $4.20 worth of photocopies here or something. So the ways that we can think about this, just trying to work this one out, I'm thinking 35 cents times that by 2, and we're at 70, 0.7 or 70 cents, and I'm thinking 7 times 6 has got to be $4.20. Okay, so what do I need there? The value of P will be equal to 2 times 6, which is 12. Okay, so I've got my answer, and that works for me. Now, what I would encourage you to do, it's hard to work in decimals. So you can use your knowledge of equivalent equations, and I'm just going to write out the original statement here, 4.2. What happens if we multiply both sides by 100? We end up with 35p equals to 420. And again, we can divide both sides by 35, and we'll end up in the same spot. P is equal to 12. We might have got on our calculator to do that and work that out. So what I'm leading towards is this idea where I want to take that equation again, and I've just changed the color of my pen here to 420. Now there's a couple of bits of information here. I'm thinking about 35, as 5 times 7. I've broken it down into its prime factor form, and I've got to do the same thing to 420, and I'm just going to pull 2 out as a factor, and then I'm going to pull 2 out as a factor again and halve that number, which is 105. And what I'm thinking about is 105, 3 goes in there, and it goes in there 35 times. And so 35 is familiar. I can see it as part of the equation up there. So that's 5 times 7. Okay, so I've got everything that I need, and here's just a little way I want to highlight something to you. If we change everything into prime factors, and that's equal to 2 times 2 times 3 times 5 times 7, and we divide both sides by 5 times 7, P, the value of P is they're going to cancel, and what am I left with? I'm left with 2 times 2 times 3, which is 4 times 3, which is equal to 12. And that's just a nice little game to play where, and a nice way to wrap this up, because like I said to you when I started this last section, there's just ways to bring in all the knowledge and refresh our knowledge on a lot of things that we've covered over the year. All right, thank you.